Unit 7, opener number 8, focuses on solving literal equations. So what we're going to be looking at is formulas with multiple variables in them, and the instructions will tell us which variable we're going to solve for in terms of all of the other variables. This is a really important skill when you're working with formulas, and something that's going to help you a lot in science class, or when you're cooking, or anywhere else where you see formulas, business, etc. The first equation tells us to solve for t. PV equals nRT. This may be an equation, a formula that you've seen before. If I want to get t by itself, I look at what it's attached to. It's on my right-hand side, and it's attached to n and r by multiplication. I solve literal equations the same way that I solve any other equation, which is to isolate the variable that I'm trying to solve. This one, even though it looks complicated, is actually really quick and can be solved in one step, because the n and the r are both attached to the t by multiplication. We just need to do the inverse operation, which is division, in order to isolate the t. So I'm going to divide both sides by n and by r. On the right-hand side, that means that the n's will cancel out and the r's will cancel out, and I'll just be left with t. On the left-hand side, I have PV over nr. And that's it. We've taken our formula and we've solved it for t. Formula number 2, I know for a fact, should look familiar because in your previous openers in this unit, you've used this formula when you were trying to find area of a trapezoid. This time we're going to be taking this formula and solving for B1. This one's going to have a few more steps than the last one, and I think that the first thing that I will do, just to be consistent with some advice that I've given you in the past, is anytime I see a fraction, I try to get rid of what's in the denominator as my first step. So what I'm going to do is I'm going to multiply both sides by 2. So on the left-hand side I have 2a, and I'm going to insert some parentheses here so that I'm not confused by what I'm doing. When there's a fraction and you have something in the numerator, it's sort of implied that it's in parentheses. So now that it's not in fraction form anymore, I'm going to insert some parentheses in there. So 2a equals b1 plus b2 in parentheses times h. I could distribute my h to both of those terms in the parentheses, but I think it will actually be much easier to divide both sides by h. Since I'm trying to isolate the b1, the h is attached to this quantity by multiplication, so I want to do the inverse operation and divide both sides by h. These h's will cancel and leave us with b1 plus b2. I don't really need my parentheses anymore because I'm no longer multiplying by something. And on the left-hand side, I have 2a over h. Finally, I have just one more step to go if I'm solving for b1. b2 is attached to b1 by addition, so I need to do the inverse operation and subtract b2 from both sides. So my final answer is 2a over h minus b2 equals b1. If you chose to do your steps in a different order, then your solution might be in a slightly different format. If you ended up with a common denominator, you might have something like 2a minus b2h all over h, and that would be equivalent to what I have, but I think that mine is probably a little bit more simplified and useful, but either one would be correct. So the big idea that I can leave you with is when solving literal equations, follow all of the same steps that you follow when solving all other equations. You have more variables in them, but the process is the same. You still need to isolate the variable that you're solving for and use inverse operations.